How will you show that 17 into 11 into 2 plus 7 into 11 into 5 is a composite number? Explain. Here let us consider the given numbers, that is 17 into 11 into 2 plus 17 into 11 into 5. So it can be expressed as by taking the numbers 17 and 11 as common. 17 into 11 as common, then what left over in this first expression? 2, and in the second expression 5. So 17 into 11, let us multiply. 17 1 is 17, 1 carry, 17 1 is 17 plus 1, 18. So 187 into 2 plus 5 gives us 7. So the given expression written as product of two terms. Hence we can write this as is written as the product of how many terms here? Two terms. Product of two terms are numbers, hence given expression is a composite number. So let us find the solution for this question, that is, what is the last digit of 6 power 100? We know that 6 power 1 is equal to 6, 6 square is equal to 36, 6 cube is equal to 216, and so on. 6 power n also we can identify. Here in this case, when the power is 1, units place is 6. When power 2 also, units place you can observe as 6. When power is increased to 3, then the units place also 6. In the same manner, when you take nth power also, the units place will become what? As 6 in its units place. So therefore, we can conclude that 6 power 100 also ends with the digit 6. Let us discuss about this theorem today. Theorem 1.3. Let x be a rational number whose decimal expansion is terminates. Suppose there exists a number, rational number x, and if it is terminates, that means it can be expressed in the form of p by q. It can be expressed in the form of p by, where p and q are what? Co-primes. Nothing but HCF of p comma q, which is equal to 1. Their HCF is 1. And the prime factoration of q, if you q written in the form of what? It can be expressed in the form of 2 power n into 5 power m, or nothing but where n and m are both integers which are non-negative. So for example, if you consider 51 by 100, it is a rational number, it can be terminates. If you write in decimal form, you will get as 0.51. Before finding this, we can write this 51 by 100 as 51 by 2 square into 5 square. As you know that 100 can be expressed in the form of 2 into 50, 2 into 25, 5 5s are, next 5 1s are. So here 2 into 2 as 2 square, 5 into 5 as 5 square. So it is now in the form of 2 power n into 5 power m. So when the number is going to be terminate, definitely the denominator of the expression of the rational number will be explained or expressed in the form of 2 power n into 5 power m. Let us discuss theorem 1.4. Let x be a x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 power n into 5 power n, where n and m are non-negative integers, then x has a decimal expansion which terminates. If it is in the form of p by q, where q must be what? 2 power n and 5 power n. Suppose x is in the form of p by q, here q can be written in the form of 2 power n into 5 power n, then this decimal expansion becomes terminates. For example, 21 by 100 if you consider, so 21 by 100 can be written as 2 square into 5 square. If it is written in the form of 2 power n into 5 power n, therefore this number is terminates. If it is terminating, we can express in the form of p by q, where such number is called what? Terminating decimal. Otherwise, if it is written in the form of 2 power n into 5 power n, definitely it will become terminating. Okay, let us discuss theorem 1.5. Let x is equal to p by q be a rational number. The number which is in the form of p by q are called rational number, you know that. So such that the prime factorization of q is the digit which is in the denominator place is not in the form of 2 power n and 5 power n, where n and m are non-negative integers. Then x has a decimal expansion in which format? Which is non-terminating repeating decimals. Let us consider one example. Suppose x is equal to p by q is a rational number, where q cannot be expressed in the form of 2 power n into 5 power n. If it is not able to express in this format, then x is not non-terminating repeating decimals. Non-terminating repeating decimal will get. Let us consider one example. 35 divided by 210. So it can be, so 35 by 210, first convert into simplest form. It can be cancelled with 5 table, 5 7 ja, 5 4 ja 20, 5 2 ja. So it can be expressed as 7 1 ja, 7 6 ja. So 1 by 6 you are getting. So that 1 by 6 is nothing but 2 into 3, which is in the form of 2 and 3 combination, but not in the form of 2 power n and 5 power n. Hence, this 1 by 6 is non-terminating repeating decimal. As we can observe its factors even 2, 3, 5, 7. So there exists other than 2, there exists 3 and 7 also. After even simplification, we got the combination of 2 and other different number except 5. So it becomes what? Non-terminating repeating decimal. From the exercise 1.3, let us see the first bit. Write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating repeating decimals. So first question 3 by 8, second one 220 by 400, 4 into 1 by 5, 2 by 11, 8 by 125. Here let us consider first one, in which its denominator 8, which can be written in the form of 2 by 3, 2 power 3 as 2 4s, 2 2s, 2 1s. So 2 repeated thrice, so it can be expressed as 2 power 3. So as the denominator in the form of 2 power n, therefore 3 by 8 is a terminating decimal. Its denominator is expressed in the form of 2 power n into 5 power n, where m value is eliminated, so that it is written as terminating decimal. Denominator. Let us consider its denominator 400. That is 400 can be expressed as its product of its prime factors. So let us find its prime factors. 2 into 200, 2 into 100, 2 into 50, 2 into 25, next 5 5s are 25, 5 1s are 5. Okay. So now how many times 2 repeated here? 1, 2, 3, 4 times. So it can be written as 2 power 4, and 5 repeated twice, so which can be written as 5 power 2. So now this is in the form of 2 power n into 5 power m only. So 229 by 400 is A. According to the theorem, it becomes a terminating decimal. So what is the theorem you observed? If any fraction whose denominator is in the form of 2 power n or 5 power m only, then it becomes what? Terminating decimal. Let us consider this given mixed fraction. First, let us convert this mixed fraction into improper fraction. 5 into 4 plus 1 by 5. 5 4s are 20 plus 1. So when you multiply this, 5 4s are 20 plus 1, 21 by 5. Its denominator is 5 only. Therefore 4 into 1 by 5 is a terminating decimal. If you have any doubts, we can also check by actual division. So let us divide this 21 with 5. 5 4s are 20, 1 left. So take the decimal point and 0. 5 2s are 10, remainder is 0. Therefore 4 into 1 by 5 is nothing but 21 by 5, whose value is 4.2. It is a terminating decimal value. Let us consider the given rational number, that is 2 by 11. Its denominator is 11, which is not in the form of 2 power n into 5 power m. Therefore 2 by 11 is a non-terminating repeating decimal. The fraction is 8 by 125. It is a given rational number, so in which its denominator is 125. Let's find its prime factors. 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So that can be written as cube root of 5 or 5 power 3. So which is in the form of 2 power n into 5 power m only. Therefore 8 by 125 is a terminating decimal, where the given expressions denominator is we are getting as 5 power 3 only. So 2 power n is eliminated here, only 5 power n is considered. Therefore if among these two numbers, if any one number existed also, that becomes terminating decimal. Given rational number is 3 by 8. So let us divide 3 by 8. By taking decimal point, we'll get 0. 8 3s are 24, 6 left over, and for every step we can take 1 0 after the decimal point. 8 7 56, and here is 4 left over, 60 minus 56, 8 5 40. So here when you subtract, remainder is 0. Therefore 3 by 8 can be written as 0.375, which is a terminating decimal. Now let us do the second one. 229 by 400. So in this, 229 is the numerator, which is going to be divided by 400. As the numerator is less than denominator, we can take a decimal point and put 0 here, which becomes 2290. So here, how many times let us possible see here? 2000 above 400 times. So 400 into 5 times, which gives us 2000. Then 290 is left when you subtract. Now we can take a decimal. After decimal point we can take a 0, which becomes 2900. Now we can take how many times? 7 times. 4 7 28, that is 2800, and remainder is 100. Now we can take 0 for the next step. 400 2 800. So what is the value left in this? 200. So for every step we can take 0 here. Again 5 times. 400 5 2000. So when you subtract, we get as remainder 0. What you observed here? 229 by 400, which is equal to 0.5725, is a terminating decimal. Let us check that given rational number is a terminating or non-terminating repeating. So let us convert this mixed fraction into improper. 5 4s are 20 plus 1, 21 by 5. Now let us divide this 21 by 5. 5 4s are 20, 1 left over, point you can take and put 0 here. 5 2s are 10. Then the remainder is 0. Therefore 4 into 1 by 5, its value gives us 4.2, which is a terminating decimal. Next let us see the next question, that is 2 by 11. In this, numerator is 2 is going to be divided by 11. As 2 is less than 11, we can take a decimal point here and put 0. So 11 ones are 11, 9 is left over. Then take a 0. For every step we can consider 1 0 in order to divide. 11 8s are 88. Again 2 left over. Put 0 for the next step. 11 ones are 11. Now line left over here. So we can take 0 again. 11 8s are 88. So 2 is left. So it repeats in the same manner. Therefore, here what is the digit repeating here? 0.18 bar. So that 2 by 11 is equal to 0.18, 18, 18, and so on will get. That is the reason we can write as non-terminating and repeating decimal. Therefore, it is a non-terminating repeating decimal. Eight by 125 is the given rational number. Let us check that whether it is a terminating or non-terminating repeating decimal. So in which numerator is 8, to be divided with 125. As numerator is less than denominator, so let us consider a decimal point and put 0. Even though is 80 divisible by 125, let us check how many times possible. 0 times. 125 zeros, 0. Then we can write 80. So in the next step we can take one more 0. Then it becomes 800. 800 is divisible by 125. 6 5s are 30. 6 2s are 12 plus 3 15. 6 1s are 6 plus 1 7. Then when you subtract we get 50. Then in this step also we can take one more 0. Now 500. Let us see how many times it is possible. 125. 3 times means 375. 4 times let us check. 4 5s are 20. 4 2s are 8 plus 2 10. 1 carry. 4 1s are 4 plus 1 5. So 4 times you are going to get exactly 500. Then the remainder is 0. Therefore 8 by 125, which is equal to 0.064, as a decimal point after we have finite number of digits. Therefore we call this as a terminating decimal.